Now let us come to this important topic of lung mechanics. Now, why are we going to study this and why are we going to review this? What concepts are we trying to derive from this for the USMLE? Well, there are certain concepts they will ask us. First of all, one, they can ask us, if the recoil force is measured to be plus 5 cm water and the intrapleural pressure is measured to be minus 5 cm water, all in mean pressures, what would you expect the lung volume to be? That's one concept or question they can ask us. Second concept that we want to grab from this topic is, during inspiration, how can we describe airflow into the alveoli? A, greater at the beginning of inspiration, greater at the mid of inspiration, greater at the end of inspiration, equal throughout inspiration. That's the second concept we want to draw. When do we have the greatest airflow into the alveoli? Is it equal throughout inspiration, or are there differences, and if so, when? The third concept we want to derive from this discussion at the end of it is, if you're asked, at the end of deep inspiration, what would you expect the alveolar pressure to be? Plus 2, plus 1, minus 2, minus 1, 0, all units in cm water. What would you expect the alveolar pressure to be at the end of deep inspiration? Another concept we want to drive from here is, suppose you're told a patient was diagnosed with pulmonary fibrosis. Which of the following would you expect? A, a decrease in the ability to develop negative alveolar pressure. A decrease in the ability to develop positive alveolar pressure. Alveolar pressure increases. Alveolar pressure decreases. Things like that. At the end of this discussion, I'm hoping that you will be able to answer all four of those concepts that we have, or questions on those concepts that we have just listed. So let's dive into it. Are you ready? Good. Lung mechanics. Of course, before we start to talk about lung mechanics, I must remind you, of course, respiration involves inspiration and expiration. And you know that inspiration is a very active process. Inspiration is a very active process. What do we mean by inspiration being active? There is contraction of muscles. Contraction of muscles. Of course, the main muscle of inspiration is the diaphragm. Contraction of the diaphragm. There are also accessory muscles, intercostal muscles, etc., but the main muscle is the diaphragm. Now, expiration is a passive process. What do we mean by a passive process? There should be no muscle contraction during expiration. If you're examining a patient and during expiration you're examining the respiratory system and you say, Mr. Jones, I want you to take a deep breath. Well, you should feel the tenseness of muscles. Mr. Jones, I want you to blow out. I want you to blow out in a calm way, slowly, and he exhales, and you're palpating. If you find that there is tenseness, there is tightening, there is contraction of muscles, you should be alerted to that. When you're observing the patient during breathing, you should also be alerting yourself to the fact, is he contracting muscles during expiration? If this is occurring, then you should start thinking of a possible pathology. So let's conclude. During expiration, this should be a very passive process. So what are the forces acting on the lung during inspiration and expiration? There are two forces. Of course, one must be careful about units, and we are using the unit of cm water, and cm water, 1 cm water is approximately 0.74 millimeter mercury. There are two forces acting on the lung during inspiration. The first one, two forces, lung recoil and intrapleural pressure. Let's talk about each one of them. Lung recoil. I'm sure you've, as a child and even now, enjoy blowing a balloon. When you're blowing a balloon, what is happening? You're adding pressure to the balloon. As the balloon expands, you've noticed something. The tension in the wall of the balloon is increasing and increasing. That's why when you release the balloon collapses, forcing the air out. Children love this, and the balloon dances about the room. Why is the balloon collapsing? Because as you're expanding the balloon, the tension in the wall, this is recoil force. The tension in the wall is increasing as it expands. And this tension in the wall will now serve to collapse the balloon. So therefore, recoil force or lung recoil is the tension that develops in the wall as the lung expands. Important. This serves to collapse the lung. When you think of recoil, the word recoil, to recoil, this is a collapsing force. The other force that acts on the lung is the intrapleural pressure. Now the intrapleural pressure, this is due, if this is the lung, and we said that the lung is surrounded by the pleural cavity. The pleural cavity is a sealed cavity, and therefore it is a vacuum. The intrapleural pressure is the pressure in the pleura, a sealed cavity. This intrapleural pressure is subatmospheric. It's a vacuum, and it's served to expand the lung. It's an expansive force. It expands the lung. The more negative the intrapleural pressure, the more it will expand the lung. That's the key point. The more negative the intrapleural pressure, the more it will expand the lung. These are the two main forces of pressure. Let's summarize. If the intrapleural pressure is greater than the lung recoil, we said, what does the intrapleural pressure do? It's negative. The more negative it becomes, the more it will what? Expand the lung. So therefore, when the intrapleural pressure is greater than the recoil force, we will have lung expansion. The opposite is true also. When the intrapleural pressure becomes less than the recoil force, what does the recoil force do? It collapses the lung. Therefore, when these two forces are at equilibrium, the lung neither collapses nor does it expand. When the intrapleural pressure is equal to the recoil force, the lung is said to be in a stable state. Now, let us look at the lung and see what is the intrapleural pressure, what is the recoil force, and the alveolar pressure in the normal lung.